I can't get my camera. So I see 13 people so far. I think there's a couple of people missing. I'll wait a minute or two before I start going over homework. There's one of my missing people. All right, so I'm going to pull up the answer key for the Chapter 2 homework, which should also be posted to the page that says homework answer keys. There should actually be 2 files on there now. One file for Chapter 1, which we already went over about a week ago. And then I posted the Chapter 2 homework answers yesterday, I think it was. Let me find share screen. Figure out where I put it. All right. All right, so a lot of the stuff on the front page is relatively straightforward. Some of it's just to kind of make sure you're paying attention to the right types of information. 2 pieces of information in each box. Obviously, each box represents an element on the periodic table. I listed 4 things on the answer key. Depending upon which version of a periodic table, there might be a couple of additional things. So symbol and name, atomic mass, atomic number. Some types of periodic tables have things like isotopes or oxidation numbers. Those 4 listed are probably the most common ones that you will see. 3 standard subatomic, meaning smaller than an atom, so proton, neutron, and electron. which one's biggest? The neutron by a small amount. Remember that I have a goof in my notes that's correct in the textbook though. Which ones are in the nucleus? The protons and the neutrons, not the electrons, according to standard theory. Again, for number 5, just trying to make sure you guys are paying a little bit of attention to some of the notable famous dead guys that are listed in both notes and in the book. People also gave me things, some other names in addition to the ones that were here. Somebody told me about the guy who invented perfume. I was not familiar with that name. So that's, it kind of depends upon what you turned in there. Nobody gave me things that sounded really way off. Atomic numbers. Remember that atomic numbers are your whole numbers. It's also the number that controls where the element is placed on the periodic table. Hydrogen being 1, helium being 2, and then you skip down to the next line, and it starts with lithium and keeps on going. So cobalt 27, palladium 46, fluorine 9. Then the other major number information from the periodic table, atomic masses. These ones, remember, according to the average weight method, or the weighted average method, to say it actually more correctly, most of these are decimal numbers. 14.01 for nitrogen, 52 for chromium, 79.9 for bromine. Then I gave you specific isotopes for these elements. Since Microsoft Word will not let me write an upscript number over top of a subscript number, and the subscript number is actually what identifies your atom anyway, I just gave you the particular isotope by giving you the mass. Remember that you must subtract mass minus atomic number to find your neutrons. That way, the 41 isotope of calcium gives you 20 for protons, 20 for electrons, but 41 minus 20 for the neutrons. Isotope 96 for molybdenum, 42 for both protons and electrons, 96 minus 42 to give you 54 for neutrons. And the third isotope there, the 209 version of bismuth, 83 for protons and electrons, 209 minus 83 gives you 126 for your bismuth. Then I gave you 3 isotopes of krypton. This is another one of these cases where there are actually more than 3 isotopes for krypton. I picked some of the most common ones and kind of ignored a few of the additional ones that are only worth a % or so. Basically, I cooked the data a little bit. Keep in mind that you must multiply your atomic mass times your % abundance, but you must move your decimal point. So the 14.25% then becomes 0.1425 when you're getting ready to multiply. Do that for each of your 3 elements there, each of your 3 isotopes. You get 11.4, a little over 57, and 15.35. One thing to point out, because I saw this error a couple of times, don't divide. This is not a traditional way to do an average. By the time you have accommodated the fact that there are different % abundances, once you get to that final step and you add them all up, don't divide by 3. Okay, it's not done in the traditional way that math does a mean, M-E-A-N. I think I spelled that right. What group does barium belong to?
I have a quick question.
Yes.
For number 9, how did you get 0.67, like 9. Where did you get the extra 0 on the end?
I did everything in two decimal places. If it's 67.9%, you can put zeros on the end. That doesn't actually change anything. If you just multiply it by 0.679, you get the exact same answer.
Because I don't think I got, unless I did my math wrong. I probably did my math wrong.
Because that one was for isotope 84.
Yeah.
And then if you multiply it by 0.679, I might have rounded the third decimal place. Let me look on my calculator. If I do...
Because I get 54.32. Wait, but maybe hold on.
54, that would give you a number that's not terribly close.
Okay, I see. I multiplied by 80 instead of multiplying by 84.
Oh yeah, make sure you match them, okay? Since I had 3 isotopes, they're all matched with a different percent abundance.
Okay, yeah, because all my numbers are a little, like instead of getting 83, I got 81 for my answer.
Yeah, if one of those was multiplied by a different isotope number, it will definitely change your ending answer.
Okay.
Would this be the only situation where you wouldn't divide by 3 to find the average? Because I think I missed this part in the notes.
For the most part, except for lab data, we are not doing traditional averages at all.
Okay.
Pretty much all of the averages that are done over the first couple of chapters are all weighted averages. Like for instance, like I said, hopefully everybody's done lab by now. The thing where you put the 7 milliliters of water into the small graduated cylinder and you do it at least 3 times and then it says average your data. That one is add them all up and divide by 3 because it's lab data.
Mm-hmm.
All of the other ones that we are doing for problems are weighted averages. So there is no division step.
Okay.
One more quick question.
Yes.
When on number 9, I think my biggest mistake was I looked at the notes and I put my percents with the wrong krypton. So just go in order. This, if you got the way you see it, is put the match it one for one, so to speak. Say, hey, 80 go with 14%, and then
yeah, that's actually why I put the word respective in there. Respective was supposed to mean that they are in the same order. 80, 84, 86, then matches with the 14, the 67, and the 17.
Okay, that's why I messed up. I got you. Thank you.
Other questions on that one? Okay. Alkaline earth metals, because it's column number 2. It's the one that has beryllium at the top of the column and then keeps on going down there, and Ba is in that column near the bottom. Metals, non-metals, semi-metals, everything there in your first column, iodine, sulfur, and selenium, are all non-metals. Calcium, obviously traditional metal, aluminum, and actually, no, I have another goof in I know I graded them right. I'm just looking at my answer key. It's not supposed to be semi-metal. It's supposed to actually be metal. I need to go back and fix that. I think I was doing cut and paste when I was putting these into the answer key. It's actually supposed to say metal. For aluminum. Arsenic is the only one that is guaranteed to be a semi-metal of that set. Arsenic, germanium, and gallium are the ones that you kind of never see called anything other than semi-metal, metalloids. All right, some people I know on number 12 did not give me the full charge. Just saying it's positive or just saying it's negative was not sufficient. The idea was, by learning what charges these elements like to make, that's why it says most likely, it helps you as you get to the nomenclature part. Calcium's in the same column as barium, so it's a +2. Aluminum's under boron, that's what makes it a +3. Rubidium's an alkali metal, first column, so it's a plus or a +1. And sulfur is underneath oxygen, therefore it is a -2. And then we get into the actual nomenclature. Keeping in mind that OCl is a polyatomic by itself, so it becomes sodium hypochlorite. We've got carbon disulfide. You are allowed to use the di because both of them are nonmetals. A number of people chose the wrong element name for Mn. Mn is not magnesium. Mn is manganese. And it must have a Roman numeral because it is a transition metal. Manganese 2. Barium cyanide. Cn is your cyanide, polyatomic. Now you actually hit magnesium. MgS is magnesium sulfide. And the last one at the bottom of that part of the row there is phosphoric acid. Your tip off that it starts with hydrogens. The top of the other naming set there, sulfur dioxide. Again, we are dealing with the fact that there are no metals, therefore you are allowed to use prefixes. Ammonium sulfide, the NH4 is one of the relatively rare polyatomics that is positive. Potassium carbonate, keeping in mind that the CO3 is the carbonate part. For the next two, we hit transition metals again. Ni is nickel, and because it is stuck to 2 phosphates, it is a nickel 2 phosphate. And the one below it is an iron 3 phosphate because of the fact that phosphate has a -3 charge. That means your iron, your single lonely iron atom must have a +3. The last one there, you can call it calcium bisulfate or hydrogen sulfate. The bisulfate is tied into the older naming system where it has the icanus endings. You will sometimes see bisulfate, bicarbonate used, but it is equally valid to call it hydrogen sulfate.
I have a quick question.
Yes.
So I, put the 2 in like for nickel 2 phosphate, I put 2, and then in your comments you said use like Roman numerals. Do you not accept like 2
Yes.
and 3?
No, you have. They have to be Roman numerals.
Okay.
Okay. Putting traditional Arabic numbers is not the way the nomenclature works.
In iron 3 phosphate, how do we know that phosphate is -3?
Okay, so because you guys are using the table either in your lab book or in your textbook, when you look up phosphate, and there's a whole table of polyatomic ions, you can see that PO4 has a -3 charge. And since we're always shooting to make neutral molecules when we're making a full molecule, that means your
From chapter
iron
2?
has to be equal and opposite. So if the phosphate's -3, that means your iron has to be +3. They
Is
gotta
it the
match.
lab book chapter 2, right?
Yes. It's about 2/3 of the way through chapter 2, but there's also a full page of ions and polyatomic ions in your lab book also. Both of them have good resources. And then going to the last set here.
Excuse me. You're talking about this table, right?
I'm trying to figure out, can I see people? Yes, that one's in your lab book.
Okay.
and it has all sorts of polyatomics, and it tells you the name, and it gives you the formula, and then it also tells you the charge. In fact, I actually think the lab book groups them by charge.
Okay.
All right. The last set gave you the name. You need to put a formula. So tetrafluoride tells you by way of its prefix that there are 4 fluorines. We've got dioxide, so ClO2. Then we switch over to a polyatomic, potassium nitrate, nitrate being the NO3 portion. Back to transition metals again. Iron 3 means you have at least 1 atom of Fe+3. And then how many nitrogens do you need to match that? Well, you only actually need 1, because nitrogens are -3. So if you have a single iron +3, you only need 1 nitrogen to go with it. For the bottom, I can tell automatically by the people who gave me a thing that was not parenthesis driven, who used Google to find that answer, because Google doesn't give you answers by priority. It gives you by most common search function. In order to have correct nomenclature, you must report them in the correct format. So the chromium has to be in the front. The ClO4 must be enclosed within parentheses with your 3 on the outside, because that is correct inorganic nomenclature. Last column, titanium for iodide. Look at your Roman numeral. Your titanium has a +4 charge. You have to have at least 1 atom of that. Iodides are halogens. Therefore, you need 4 of them to match up because they're all -1s. Look at the ending on your acid. It says sulfurous. Therefore, it must have come from a sulfite, ITE, original ion. Rubidium peroxide, I kind of tossed that one in. That one kind of makes use of the fact that peroxides are only allowed to stick to group 1 elements, and they must be metals. Or metal-like, because hydrogen actually gets included in that. Barium hypobromite, remember that fluorine, chlorine, bromine, and iodine all follow the same pattern. So hypo means you have a single oxygen attached to your bromine, but that whole thing enclosed in the parentheses is -1 to match up with the +2 of your barium.
And it doesn't matter that we put, if we switch the O and the B.
Yeah, actually, even textbooks are inconsistent with that. I've seen, actually, I think your lab book doesn't match your textbook. I think one of them actually says OBR, and the other one says BRO, so I will take that one either way because it does, there's inconsistency in the textbooks. And the last one, permanganate, make sure you have your MnO4 in parentheses. Because it is a nickel 2, you need 2 permanganates. Permanganates are only worth -1. Okay, other questions regarding the homework set?
Are a couple of these going to be on the test like exactly the same? Or
Doubtful. I usually pull random combinations for doing that. So
yeah, I'm surprised I got so many right, but it literally took me the whole night to finish this part.
Nomenclature really, truly, a lot of people talk about it as if it were learning a language. And it really kind of mimics the concept of learning a language.
So basically we have to memorize the things from the lab book and the ending.
Well, because you are allowed to use your lab book and your textbook and your notes if you so choose, just not internet sites or each other. You don't actually flat out have to memorize them, but you do know how to you have to know how to use them. If this was a different kind of a class, there would be flat out memory involved.
I just studied these things in my high school back in another country, and I know they kind of make it in some special order that it would be easy to memorize. I just don't remember. It was like 12 years ago, so I just have to look it up again.
I've never seen like a mnemonic that like uses like letters of the alphabet that it's like supposed to help you remember it. I can't say that I've ever seen a memory trick for polyatomics. Usually it's really seriously brute force memory. It's kind of like when you take anatomy and physiology, you have to know the names of all the bones and you have to know the names of all the muscles. In chemistry, it's the names of the elements and the names of the polyatomics.
Yeah, I never paid attention because I didn't know that in 12 years I will need it again.
Yeah, it kind of comes back to haunt you. All right, let me see if I can invoke the whiteboard thing to talk about things you need to think about for your test. Remember, the test goes live tomorrow morning. All right. I am just kind of using a test from, I don't know, a few years ago because I always focus on the same types of topics. So things that you need to consider, okay? Homework is a key feature. Things of the type that I ask you to do on homework are definitely gonna also appear on the test. Things that you need to think about, and these are only sort of loosely grouped by chapter. They're not grouped in the order in which they appeared in the chapter. So when we did temperature, remember that we've got Celsius and Fahrenheit and Kelvin. So as in the homework problems, you are going to need to be capable of translating, converting from one kind of temperature to another kind of temperature. You should also then be able to convert, we'll call them the SI units, basically the metric stuff. Remember that there are 5 prefixes that we see extensively. One big one, kilo, then we've got deci, centi, milli, and micro. Those are the ones that we see all the time. Make sure you are familiar with how you can go back and forth between, say, kilo to milli or a single unit to micro. Also things that, these were also things that were covered in the labs that were done over the past couple of weeks. We talked about some basic stuff. We talked about scientific method to some degree and some basic kind of types of chemistry, some conceptual stuff there. We talked about subatomic particles. That was actually part of tonight's homework. The idea that, I'm spelling that wrong. I can't spell. Protons, neutrons, electrons. Obviously, the protons and the neutrons are in the nucleus. Electrons orbit around the outside. We did sig figs. Again, looking at your homework set should prove helpful. There are 2 main types of problems in that sometimes we just look at a number and I would ask you, how many sig figs are in this number? But also, again, back to homework, I might give you a simple mathematical problem and ask you to report your answer with appropriate numbers of sig figs. Keep in mind that there are two different rules for that. There's the adding and subtracting. Actually, that didn't look right. Adding and subtracting rule. But then there's also the multiplying and dividing rule. So two different rules depending upon which mathematical function you are doing.
What happens if you do both? Like if you add something and then you divide, like does it matter at that point?
I specifically did not give you combination problems for a test.
Cool. Okay.
In a laboratory situation, it usually ends up using the last rule that your calculations involved. Dimensional analysis. There are several, including a messy one. Let's see. We also spent a little bit of time talking about chemical and physical. We did both properties and we did changes. So make sure you have some concepts about what the differences are. And again, this kind of got touched on a little bit in homework 1, things that you need to think about in terms of which ones are which.
A quick question, just to make sure I'm getting this right. You said the test goes live tomorrow, right?
Yes, it should go live actually at like 1 minute after midnight tonight. Okay, well, as soon as it becomes Friday, technically it goes live, and you have 4 entire days to choose when you want to do it. But once you start it, it will only give you a 4-hour continuous time limit. So make sure when you sit down to do it, you like don't have to go to work or something like that, because you can't stop it and restart it. Once it starts the clock, it continues your countdown.
Okay, yeah, that's what I want to make sure of right there.
I truthfully don't expect it to take 4 hours, based upon the number of problems and the fact that there's a mix of mathematical problems and other items. My estimate would be that it would be capable of being completed in about 90 minutes. But not everybody works at the same speed. So I went ahead and decided that I would put a 4-hour time block on it.
So
Okay.
I have a question.
Yes.
After we take the test, are we gonna are you making comments on it like you do our homework? Are we gonna go over it? Like, how does that work?
I will definitely make comments on it as much as I can, because the system, let's see, the one for homework, I can click on a spot on the page and it will let me sometimes write on the page, and then I can put other comments in a box.
Yeah, I seen the box.
I know that I can put comments in the box on the test. I am uncertain if I can write comments on the actual test file. But I will definitely put comments on this for to indicate things about where it went wrong. It will take me several days to crunch through all of them. I am, because I've been doing this for a long time, to grade a stack of physical papers takes me less than 2 hours for an entire class, because I know exactly what I'm looking for and I can write literally on the pages. Doing it digitally takes about 5 times as long. So I will get them done in all probability before a week from tonight. I may or may not get them done before class on Tuesday because the testing site locks down at midnight on Monday. So that means I have daytime on Tuesday to grade papers, but like I said, they take a while. Now, if some people end up taking the test by random chance, earlier in the weekend, I will kind of start grading them probably on Sunday. I hope that maybe I can have them graded prior to class time on Tuesday, but I'm not sure.
So are we gonna ever go over it, or?
I don't have the ability to do that.
Okay.
I cannot pull a quiz because that's how they're categorized by the Canvas system. I cannot pull it from my side to display it.
Mhm.
So not really. It's like that's why I'm gonna try to put a fair number of comments on them, but I can't really go owe them. In fact, even though later I can go back after everybody has completed the test, I can go back and activate the answer key that will only show you the non-multiple choice ones. Actually, I said that backwards. That will only show you the not problem answers because everything else has to be manually graded by me.
Mm.
It is not a great system.
Mm.
I will try to make as many comments as possible. Let me keep going with the list here. So let's see, we've gotten all the way down through chemical and physical properties and changes. Oh, density. Density came from chapter 1. And that's all the major parts of chapter 1. We also then need to throw in there isotopes, which just like the homework set, how many protons, how many neutrons, how many electrons based upon which isotope. Non versus metals versus semi-metals. I hope I spelled semi correctly. What did it do that? Hang on. It did something weird. There, okay. Let me go back down here to where I was. Text. All right. Actually, let's try this. Text. Start another column. Column names. This also ties into your homework set of where I ask you that the barium, which group it belonged to. So keep in mind alkali metals, alkaline earth metals, halogens and noble gases, the giant chunk in the middle that's all the transition metals. All of those are sort of column name information. Weighted average. And then the last thing is going to be names, formulas. Just like homework, some of them will give you the name and ask you the formula. Some of them will give you the formula and ask you the name. Now, one thing that is true, because this is an open book test, like I said, you may use your homework, you may use your notes, you may use your textbook, your lab book, just not each other, no websites. The lockdown browser, once you open the test in the lockdown browser, which is how it functions, you cannot open any other websites on your computer. That's the way the system functions. But because it is open book, there's not really recall questions. For instance, in a more traditional test, one of the things that I usually put on there is I usually put about a half dozen, what's the name of this element? And I give you a handful of symbols. Or what's the symbol for this element? Because it is open book, I'm not doing that kind of questions. What I usually refer to as like just sort of recall questions. Most of the ones that are short are a little deeper. You have to read the question and determine what is being asked in order to pick the correct multiple choice, or there's a few true false and some other odds and ends. I believe there are 46 questions that vary in point values from 1 to 6, I believe. It should, when you open up the test, it should display as part of each test question how many points each of the questions is worth, so you can make determinations on how much time you want to spend on problems worth more points versus problems worth less points.
So it's not the type of test where if you answer a question, you click next, you can't go back. You can like go back and forth.
I believe so. I have not done it from the student end, but I believe up until you hit submit,
Okay.
I believe you are allowed to scroll back up. And it will not show you answers even after you submit. I will not activate that function until after the test closes on Monday night. I'll go back and activate that function later.
And so when you activate the answers, it shows us the answers.
It shows you all the non-problems.
Oh yeah, you did. Yeah, you did.
So like for instance, if I gave you a density problem and I said, this block of wood weighs 6 grams and takes up a volume of 12 grams, what's the density? But it's not a multiple choice question. And maybe it was worth 3 points or something. I have to go view the question and put the number you got correct in the box. And then when I get to the end and I hit, let's see, I think my end of it says adjust or recalculate or something like that. And then it totals up all the ones that were auto graded plus all the ones that I graded. And then I hit submit, and then it loads it to your grade column on Canvas. So I don't know that you know which ones you got right when you submit it. In that way, I think it's kind of like a traditional test. When you hand in your paper, until you actually get your grade back, there's kind of no guarantee which ones you got right and which ones you got wrong.
Okay.
Other test-related questions? I want to do just a little bit of Chapter 3 tonight. Remember, Chapter 3 is not on this test. Chapter 3 is about 2 weeks from now, well, probably almost 3 weeks from now.
I understand that Chapter 3 isn't on the test. Is anything from the second 2 lab assignments going to be on the test?
I believe it was 2, we'll call them general knowledge questions, not anything too very deep that were lab related. Because some of you do not have me for lab. So I put 2, they're not worth very, very many points. I think they're each just 1 point questions. But there's a couple of points that are lab, kind of generalized lab information. Not a lot, just a little bit.
All right, thank you.
Other questions? All right, so I'm going to kill off the whiteboard and figure out where I put my Chapter 3 notes somewhere. 3 notes. All right, we got the last thing we talked about on Tuesday was the multiple atom empirical formula. So I think that's the last one I did on Tuesday. So we're going to pick up with a variation on this. Not everything that you see that asks you to calculate an empirical formula will give you grams as your starting point. Sometimes they're going to tell you percentages. Okay, go back and think mathematically about what a percent means. Percent means some number out of 100. So if you had 12%, that's 12 somethings out of 100. If somebody in a lab presented you with a sample of iron ore and told you that this sample is 18% iron in the ore, what that is essentially telling you is that you've got 100 grams of sample, but of that 100, only 18 of them are actually iron, and the rest of it's something else. One of the ways to deal with this, one of the traditional ways to deal with this, is if your information is given to you in percentages, you start with an assumption. You pretend you have 100 grams. Occasionally you'll run across problems where it tells you something like, oh, well, the sample was 11% carbon, but the sample itself was only 5 grams. Then there's more math involved. We're not going to dig deep into those particular problems, but I think there might be one example in your textbook that does a variation on that. So do be aware that it does exist. I picked one here that has sodium, silicon, and fluorine in it. And I gave you percentages. The rest of it looks very similar in style to the previous examples. We're gonna move, not really even move our decimal place. We're gonna change our symbol. Instead of using a percent sign, we're gonna assume it's grams because of the idea that you are starting with 100 grams. 24.5 grams of sodium, 14.9 grams of silicon, 60.6 grams of fluorine. And it starts the same way the previous problems do, whatever. You're dividing by the number from the periodic table. So sodium gets divided by 22.99. Silicon gets divided by 28.09. Fluorine gets divided by 19. Now note, one thing that is typical of this style of problems is the number of moles you're getting in this first segment here, 1.07, 0.53, and 3.19, are kind of bigger numbers than we got in previous examples. The reason being that you're starting with a higher number of apparent grams. Therefore, you will have a larger number of moles. Pick your smallest one, because I've got 3 elements, so I can't just do a 1-to-1 ratio. I got to pick my smallest one, which in this case was my silicon. Divide each of these by 0.53. And again, I gave you slightly imperfect data. You get 2.02 for the sodium and 6.02 for the fluorine, which I then rounded to give me 2 and 6. And then I sort of just spit it back out in the order in which the data is presented. Sodium, then silicon, then fluorine. So my empirical formula, Na2, Si, F6. Keeping in mind that my silicon has the implied but not written 1 beside it. Now there is one variant on this. What happens if you did the division step and you end up right in the middle? You can't, unlike the problem there above, okay, 2.02 obviously rounds to 2. 6.02, oh yeah, we can see that that rounds to 6. What if you end up dead in the middle? On a purely realistic note, in higher levels of chemistry, you need to accommodate the fact that not only do halves occur, sometimes you have thirds and quarters and fifths and some other things. However, for general chem, we only really embrace one variation here. And I picked on magnesium and nitrogen. Starts the same way. Take your 0.710 of magnesium, divide by its atomic mass, you get 0.292. Do the same sort of thing with your nitrogen there. 0.273, divide by the 14 that was on the periodic table, you get 0.0195. Divide by the smaller one. But now's where it gets to be the messy part. Because when you divided the top one there, I got 1.5. Well, okay, rules of math, generalized rules of math, imply that you are supposed to round up. 0 to 4, round down, 5 to 9, round up. You're not allowed to do that with empirical formulas. If you are basically dead smack in the middle, you have to multiply everything by 2. What this also does for you is it allows you to create molecules like the one shown there of Mg3N2 that have one odd subscript and one even subscript. We could even puzzle that out based upon the traditional charges for magnesium and nitrogen. Magnesium is an alkaline earth metal, which means it likes to have a +2 charge. Nitrogen generally has a -3 charge. Based upon those ideas alone, we would come up with the formula of Mg3N2. So one more extension on this. What if you know the empirical formula because either it was given to you or it was calculated for you in a previous part of the problem, and you want to actually know what the molecular formula is, keeping in mind that sometimes they're the same and sometimes they're different. So I created one here where I gave you the empirical formula as your starting point, C2H F4. But then I gave you an additional piece of information. And it's not an exact. Note it says approximately 200 grams per mole for your molecular weight. Well, I need to figure out what would it actually weigh if in fact I did only have exactly what's written, 2 carbons, 1 hydrogen, 4 fluorines. So I did my little laundry list, 2 C's, 1 H, 4 F's, looked up my values on the table, 12.01, 1.008, 19. And I totaled all of that together. 1 unit of empirical formula weighs about 101. So I compared that versus the data I was given that says my molecular weight's about 200. 200 divided by 101 gives you 1.98, which really close to a whole number. So I'll go ahead and round it up to 2. Your textbooks may do this one of two ways in reporting their data. C2HF4 is sometimes written inside parentheses. Put the 2 on the outside, meaning you have 2 units of that. I have equally as often seen the alternate version of that where they went ahead and multiplied it out. So that way I have C4H2F8. Both tell me the same information. It's kind of a matter of format. I have seen it both ways in terms of how textbooks report answers to problems. I will take it either way, so long as your math is correct, because there doesn't seem to be an absolute consensus on which is the best way to report this. And actually, I'm not going to get into the hydrate part, I think, until Tuesday. But it is tied into the lab that is one of the labs that is upcoming. And actually, it ties into one of the physical you're going to actually do at labs. For those of you who have me for lab, I am probably going to activate the page that shows where the metathesis lab is. I don't know if I can actually go backwards and show that. I think it logged me out. Yeah. Let me go back and see if I can pull this up. Screen share. All right, this is probably not exactly the way it looks for people who have lab, but close. Remember that I have transferred a whole bunch of stuff over here to pages. I wish, this is something that I don't know how to fix. Actually, I don't even know if there's a way to fix it. They're alphabetical as opposed to allowing me to do it in the order in which you're doing the labs. But this one here that says metathesis dry lab, that one is not currently viewable, but will probably become viewable in the next few days. It is the next dry lab that comes up after dry lab 2 here. Dry lab 2 and separation of a mixture are the rotation for the next 2 weeks. And then after that, metathesis is going to be the next dry lab. I am in the process of making videos and taking pictures so that you have at least nice visuals to do your observations from. So hydrate is actually going to end up being a part of all of this once I get all of that kind of dealt with. It's a work in progress, as kind of all of this is. Questions? Test goes live basically tonight at midnight. You have 4 days of time period to choose from. You are allowed 4 hours once you start it. Make sure you have a calculator with you. Lab book, textbook, notes, homework, all of those are valid to use. Obviously, show work when asked for. No website stuff. No each other. I think those are all the pertinent details.
When we click on the link, it will automatically direct us to this this specialized website, right?
I believe so. I believe that when you click, because I loaded it through the lockdown browser, and so it should, once you click on test, it should take you to the test and probably gives you just a presentation page to start with that basically says, this covers chapters 1 and 2. I think I put like 2 sentences on the initial page. And then once you hit go, then it should begin to display questions for you.
So we don't have to worry about downloading anything on any.
No,
computers or devices.
what I was told. Okay, we didn't use this in the spring. This is new. Okay, what I was told was that once you hit go, the system takes care of it.
Okay.
Kind of like Zoom. It's like when you don't actually. I mean, a lot of you probably have Zoom on your phone or Zoom on your computer anyway. But if you didn't, you can just go in through your student account and hit Zoom, and it just does it. So my impression is that's the way the lockdown browser works. I know that my son is taking calculus. His professor for the calculus thing actually used an external website called Lumino, which supposedly works the same way that lockdown browser works. But it's actually designed for math classes. And once you log in, it shows you the clock in the upper right hand corner. It shows you the clock and it counts down because he had a 3-hour window for taking his calculus test. And I think it allows you to scroll back and forth up until you hit submit. And then once you're done, you're done.
What should we do if we have any issues as far as?
I will try to be available for email stuff most of the day, most of the weekend. I have a couple of things intermittently, but I check my Verizon one usually every couple of hours because I'm usually in the middle of doing something else and I'm on and off the computer kind of all day long. So if it like locks you out of the system before you ever took the test, if it doesn't allow you to log in, definitely send me email and I can maybe fix it during the day tomorrow. Because tomorrow's a work day, which means tech support will be around Saturday and Sunday. Canvas tech support is supposedly available 24/7. School tech support, I'm not sure about.
Okay.
We didn't have any problems with the system the first way back in the spring because we did it through Canvas and it worked okay. The only extra layer that has now happened is this additional lockdown browser thing. I haven't heard any of my colleagues like blowing a gasket about like, oh my God, it crashed and this is test week. Okay, I'm for those of you who have other classes or have friends in other classes, math and science tends to follow kind of a predictable pattern. My son had a calculus test this week. My daughter had a quiz this week. It's like every 3.5 to 4 weeks, there's kind of this rolling occurrence that tends to happen in most non-English history classes.
Yeah, there's a test in pre-cal and trig this weekend too. So
we all end up kind of following the same chunking method. We all tend to do, we've done 2 chapters, it's time for a test. So a lot of times people end up with tests all in 1 week. And yeah, I'm aware that that's true. That's also why I give you a 4-day window, because some people have Friday classes and some people have work schedules that mean they can't take the test until the weekend. So that's why I put 4 days on the test window to try to give people a little bit more flexibility.
I definitely appreciate that.
We're all trying as hard as we can to make this work. The other half of my life has nothing to do with chemistry. I sent my book to the editor last night. Yay!
Yeah, congrats.
Congratulations.
63,000 words. That took me like almost a year to finish. So
What's
getting
it
it
on?
out. It's a science fiction gay romance.
Oh,
Cool.
that's cool, actually.
I have been swapping email with the cover render artist. The character that's going to appear on the cover is going to be a digital render. So my entire week has been involved with daily email exchanges with the artist who is creating the character image. And once she's finished, then she'll send it to me, and my husband will composite it with a background and titling and all of that in order to create the cover. So when you self-pub, everything gets farmed out. I have an editor, I have artists I use, I have photographers I use, I have somebody who helps me with marketing. It's a thing. That's the other half of my life.
You know when it's going to be available?
No, because part of that depends upon the editor. I spent an hour on the phone with her today, and I asked her, I said, do you have a time frame? Because I write a lot of novellas. A lot of the books I write are in the 30 to 40,000 K range, and it usually takes her about a month. This one's 63. However, she said she didn't have a huge lot of other commitments right at the moment. So she said she thought it would only take her a month to do it. But that's a little bit subject to availability. Because she has another job too. So
we all get autographed copies if we do one with that.
it's an ebook.
Oh, okay.
I mean, if I sell enough to justify having a print run done, or actually to have a print formatting done, because then it becomes print on demand, then there might be physical copies, but that would be a next year thing. Pretty much the methodology of this is ebooks come out first, because in the world of romance, 98% of my sales are ebooks. Paperback books in the romance world are something that only the giant publishing houses in New York do. Most of us who self-pub, I mean, I do have a publishing house I work for some of the books I write, but only some of those books also go to print. I have to meet a criteria of sell X number of ebooks within a quarter, a 3-month window, to be considered for paperback rights. It's my other job. All right, so send me questions if there are problems with the system. Other than that, you guys have done homework. We've spent a lot of time talking about these topics. You should do okay. And I will see you on Tuesday. Actually, some of you I will see on Monday.
Yeah.
Some of you I will see you for lab.
See you Monday.
See you Tuesday.